Hi, everybody. I'd like to welcome you to this YouTube channel for the Basic Playground. And what we're going to be doing tonight is we're going to be covering from session 2. And the first into session 2 will be reviewing that. But on this session, we're going to be learning about input statements. We're going to be learning how to print ASCII characters on the screen. And we're going to be learning loops and also arrays and maybe some other things, depending on how much time we have left here. So I'd like to welcome you all. If you have any questions, just go ahead and leave anything in the comments. I appreciate that very much, and I'll get back with you. This is an open session for anybody. So if you have questions, all you have to do is respond in the comments and ask, and I'll be happy to go ahead and answer them for you as best as I can. I also have here with me Romel once again. She's joining in. Now I have looking at her screen on it. I'm looking at her screen on a separate window, which is a special sharing environment we have over here, so I can monitor that. Eventually, what I'll be doing is I'll have this session, which is called zoom.us, where everybody can go through, and if this all is well, I'll be able to swap between any screen I want and be able to guide anybody wherever I can. So I'll be like an instructor saying, oh, click this, do this, like kind of like a multitasking thing. That's what my goal is. Okay, and also, guys, I really appreciate it if you would like to support me on Patreon. The link is actually in the description. This will help me provide more videos for you in the future. As I do this in my free time, just kind of a side note here, guys. You guys know me very well. For those who are not, I've been around the Commodore 64 since 1986. Started with my first Commodore 64, just to kind of throw that experience background there with you. And I've been on YouTube since 2009. I'm a very small person on YouTube. So if you can help me grow in any way, pennies to the dollars, I don't care. I'd appreciate any kind of support. And I'm there for you all the way. So what I wanted to also go over here is kind of what we reviewed last week. So I'm probably going to pull over to my screen here for a minute. Say hi, Romel.
Hey, hi.
Okay, you saw her there for a second. Okay, and then we'll get this underway. I just wanted to kind of review what we went over last week. Okay, let me switch over here. Okay, and just Romel will be my guide. Are you seeing my screen there now, Romel?
Yes, I do.
Okay, I had to move your little zoom out of the way here so I could watch your screen. Boy, this is getting really a tight environment tonight. I got like the YouTube down in the corner. I got the Vice up there. I'm going to try to make this thing fly as best as I can. I also need to test the audio before we do. I always have to do this every single time. So if anybody's on YouTube, I need to throw a message here real quick and make sure that they can hear audio. So I'll say, please let me know if you can hear me and see the screen. Thank you for joining us. Okay, so we got that underway. Now they're looking at my Facebook. How nice. Okay, so what I want to do here is we're going to eventually go over this. I'm not going to overwhelm you right now, but this is going to be, as I mentioned in the video here, I want to create something like this. This is just an example program if you want to try to take a look at this real quick here. This is a program I created a while back. This is kind of, and this one's a restaurant, but I want to re-emulate it and create a store where you walk into a store, you're talking to a cashier, and from there you can basically, tender money, and it's going to, with our variable results, it's going to give us, our change and whatnot and stuff like that. So that's the goal here. I'm going to keep it simple real first. I think I'm just going to keep it to the dollars. Because we're going to get into something later called floating points, and that's a whole new session, which just reminded me I need to talk about floating points too. So I'm going to pull up, I have a separate document here I wrote to myself so I can keep on track with all that here for you. Trying to keep this as consistent as I can here. So I'm going to minimize this one for now, and we're going to all start with a blank window. Now, for those who have not done this yet, you're going to want to make sure that you download, as always, the Vice C64 emulator so we can get started. This is an emulator that will allow you to write programs on the Commodore 64. You don't need to own the personal computer. You can just use it straight from the Windows environment there. So I'm going to maximize my window here a little bit. Does that look okay, Romel?
Yes.
Okay, perfect. All right, so the next, what we're going to do is a review here right now. If you guys get stuck on anything with the downloading, please send me a message in the chat or whatever. And if you want to join the Google Hangouts, also send me a message. I can send you an invite to the Google Hangouts. Okay, so just kind of a review here. Last week we were talking about essentially what was basic, which is beginners. Oh, beginners. I'm losing my mind here tonight. Beginners, all symbolic instruction purpose. Beginners. I can't even talk to it. Let me just write it on the screen here. Beginners. Oh my gosh, this is not good tonight. The beginners symbolic instruction code. I don't know why I can't think of the A right now. I'll think of it in a minute. It's probably beginners acronym or something. But anyways, beginners all symbolic instruction code. Duh. So anyways, that's what BASIC stands for. BASIC is just an emulated environment that allows you to write simple programs in a high-level language that'll be understood by the actual computer. We didn't write programs right away, but we were learning about what was called the immediate mode. And that's essentially when you're typing in a value like this, print to a number. And I'm just going to, and I just noticed I don't have my right. I opened up the wrong thing tonight. I don't believe I did that. Anyways, I'm using my old emulated computer here. So I'm emulating my keyboard as a Commodore 64 right now. So excuse me on that. I think while I'm waiting here, I'll just pre-launch it in the other window so I have getting that ready here. Okay, so this is just what's called simple math on the computer here. And just demonstrating some simple commands here. We'll just say 10. It doesn't matter which one I use. 10 minus 8. It's just a calculator, right? That's your subtraction, and this is your addition. Good thing I know where these are at. Okay, and I'll just say, like, I don't know, like 100 times 20 or whatever, or 2 or whatever. It's 200, right? And then we finally also got the, let's see what I forget here. Addition, oh, division. So we're going to do division. We'll just say 64 divided by 8. You get 8, right? And then we got the powers of the number. So I'll say 24 to the power of 2 or whatever. And you see how it raises it to the power of number. Actually, that's 24 to the power of 24. So pretty big number there. So anyways, that's we were going over simple order of operations, which is PEMDAS, which stands for please excuse my dear aunt, put down here, Sally. And that's just essentially reading the parentheses first. And that's just like taking a value inside of your parenthesis. And whatever's inside of that parenthesis is going to execute first. So it would do 70 plus 2 first. And then anything after that, it would do the additional operands that's following that in procedure like that. So would it take 2 times 4? It would actually say 70 plus 2, which is 72. Plus 4 was 76 or 76. Oh, wait, no. What did I do wrong here? It is 70 plus 2. Oh, 70 plus 2. So 72 times 4. So it's 72 times 4. Okay. Let me just test to make sure I got my editor environment opened up here so I can actually. Okay. I'm going to switch over to my other Commodore 64 screen because this one's not going to emulate like a Commodore 64 here. But it's going to still accomplish the same goals here for us. Of course, it's different colors altogether. And this is the background color. So I'm just going to change the background color to black here. And then we're going to change the text color. We also learned about that. That's just hitting the tab and the control keys. Any of those is going to, change your colors for you. Just going real quickly over that. And sorry if I'm going through this like lightning. You can always watch the other video. It's in the link. I'm just doing a quick review here. And you can list your program. You can erase your program. You can change the border color, whatnot, right? Okay. And the other thing outside of order of operations we talked about was the ASCII characters. I'd like to go into those a little bit more tonight. If you hold down and Ramel, you'll need to do this. If you hold down your caps lock key. Actually, I did that wrong. I'm sorry. Your control key. I'm trying to do it in the other window here. Your control key will give you the ASCII characters. And I think the other one is the, whoops.
What color is black for a black screen?
Oh, hold on a second. Oh, the black is the command, poke 53281, 0.
Poke.
That was from last week, remember? Okay, so anyways, I'm trying to, it's shift. Okay, I was trying to remember which one it was. It was shift. So the shift will allow us to do, and I'm just doing the alphabet right here, any of the ASCII characters on the screen. And if you put these together, you can actually end up drawing stuff. This is kind of an example there. And we'll go over that a little bit more also, Ramel, so that'll make a little bit more sense. We also discussed, in addition to the new, racing a program, listing a program on the screen. So if we have a simple program here, I'll just make a simple program. And quotes, also we discussed that too. And I forgot, it's going to be shift 2, right? Or no, it's going to be the emulated keyboard. I'll just say, hi, everyone. Thanks for joining us. Okay, and then like that, and then you got a program in memory. It did execute since it's now running a program in memory, and it stores it in memory. You have to type run, and it runs and executes the program for us. Whereas if you typed it on the line, it would just do it, immediate. Right on the screen, immediate, right away. Okay, and in addition to that, we also discussed the disk directory, which is a load string, -8 like that. I may have something pulled up here. It's saying file not found because you actually have to attach the file here. I'll just attach mine to any one of these and demonstrate. Okay, I just had someone on YouTube say they can see the screen. Audio is great. You can see the 64 screen. Thanks, John. John is a really good friend of mine. He actually joined us before in a live stream. So welcome back, John. Hey, John, if you want to join the Google Hangouts, I could go ahead and I'll paste that. I think I forgot to put that in there. Let me actually put that in there right now that I notice he's there. So he might join us here, Ramel.
Okay.
He has audio, video, all that stuff here. So I'm just going to go back here and just throw it in the chat here. There's the Hangout. So join us anytime, buddy. Okay, so in addition to that, the directory, ASCII characters, screen colors, I think that covers everything that we went over last week, unless you can think of anything else about that, Ramel. Just probably like, what? Okay. What I wanted to really go into tonight is, first of all, I'm going to screen share here for a second. So I'm going to switch back to my desktop. And I think I forgot to present to everyone. That's going to be a fatal mistake. So that means everybody's probably just now seeing my YouTube video. Oh, boy. Anyways, if you're seeing my YouTube video for the first time, I apologize. I just hit the present to everyone. So somebody did say that they were seeing it, but I just noticed I forgot to click that. So I'm going to go ahead now and share my screen here with myself. And too fast there. This is a really good book to have. This is called the Commodore 64 Programmer's Reference Guide. This book will take you anywhere from the Commodore 64 from A to Z. It's almost essential to this book. If you remember this book last week, Ramel, Mapping the Commodore 64 is your guide to the memory of the Commodore 64. Well, this one is your guide to programming and learning anything you want to know about the Commodore 64, a must-have. And the reason why I'm talking about that is I found some good information in the book that I wanted to go over here tonight. I'm going to adjust my light here a little bit. So I wrote down some of this stuff that I felt was really important. I'm just going to kind of read it here. And first, let's go back to the screen here so I can talk about the strings. Because I forgot to mention the variables. The most important. How did I forget that? So a variable is two-letter character name like that. A variable has to start with a letter. And it can end with a number, but it cannot start with a number. And it's also going to be 2 digits, although you can make them longer. I think they go up to 255 characters. But if you make them longer than 2, like that, it's not going to see anything beyond that. And if you try to print high in 2, it's still going to show 2. But later, if you try to initialize something in addition to this, it's going to create some problems. But the whole point is you always want to keep them to 2 digits and you're good. So I usually just do stuff like this, for example. And we're setting these to what are called integers. I probably didn't talk about that last week, but integers, and I just now realized I'm not sharing my screen. Darn it. Okay, let's go back over here again. Okay, sorry if you didn't just see that. So if you see right here, I'll put my mouse over here. This is a variable that we talked about last week. So a variable is going to start with a letter, and it's going to end with a number, but it doesn't have to end with a number. But if you want to put a number, you would always make it end with a number. But you can also just do regular, as we talked about last week, you can just do regular letters like that, for example. And if you print the value, you're going to see the result that's put in there. So whatever value I put in there is going to print in that result like that. Why is that important? Because as I mentioned earlier, if you try to make a variable too long, which you can make them really, actually, I think I screwed that one up. I'm just going to, a bunch of letters here. eventually you'll have some problems in the program later when you try to start make a really long variable. So right now I didn't sign that one. I forgot to sign it. The whole point is it's a good habit to get into 2 character code variables. If you can remember that rule, you should be good. Okay, so just kind of reviewing. It's really just going to take a while to review here. Okay, the next thing we learned about was string variables, and this is a string variable. A string variable is going to contain any characters in there, except it can't contain a double quote, since a double quote is what defines the screen character. So I'll just put my name in this one like that, for example. And if we print AA strings, you'll see it says Steve. Now, if I try to print something like STs, that's probably a bad example, but SS, for example, which is a blank variable, it's always going to be blank until you put something in it first. It's actually known as a null value. Okay. I think I'm along the way now. Also, variables can contain data such as integers, floating point numbers, or strings. I'm just going to read this as I was talking about earlier. So a variable is considered empty, or an integer value contains a 0 until you assign data or digits to it, like I mentioned earlier. Only the first 2 characters are significant. It's not a good habit to exceed this length. Okay, so the next thing, we're not going to go into a lot of this, but also really important since you're using a computer, which is essentially a calculator also. It stores what are called floating point values. Now, I'll just call this one FP, for example. And we'll set a floating point value. And I know I didn't show you this yet, Ramel, but a floating point value is going to remember decimals. And decimals are followed by, like you would write them in math class, right? With a dot, for example. Yep. And if you type in that value, you're going to see it. Actually, what did I do wrong here? Oh, I printed FP. Well, so I should have signed it. Okay, my bad. I'm getting ahead of myself here. So anyways, I want to go to 20.15 and then print FP. But you notice earlier when I printed FP, it was 0. Remember, it's always going to start at 0 until you assign a value to it. So now it's got a floating point value here that I could pretty much do some fun stuff with. You see that number there? That's a huge floating point number. And if you really have some fun with them after a while, they're going to do some pretty wild stuff here. Let me see if I can do a pretty crazy one. Let's see, 42. Oh, I've got my powers, my 6 key, like that. Now, if you see that E there, if I remember correctly, it's multiply it by the power of 10 plus the number afterward. And important about a floating point, I'll read this. A floating point value is either positive or negative, also allowing fractions, which is represented by a decimal point, which is the period character you see there. Commas are not used in numbers. Now, the values can range as low as, and I'll write this one on the screen, 9 digits. And that can be as high as, which is going to be a plus sign here in front of it. 9 also. So if you exceed that, it's going to start rounding off and doing some weird stuff with it. Okay, excuse me. Okay, so also variable names cannot have keywords in the middle. A keyword is like, for example, list, right? Or if you type in new, that's a keyword, right? Print, that's a keyword. Any of those keywords, you try to put them inside of a variable, you're going to get an error. The keywords are made up of all the Commodore 64 basic commands, statements, function names, which you'll learn about later, and logical operator names. If you use a keyword in a variable, you will get a syntax error on the screen if the program is running. So if you have it inside of a program, it'll actually execute out and jump out of the loop and stop the program. And also, variable names are made up of alphabet letters and numbers. I think we went over that earlier. Ranging from 0 to 9, and you must start with the letter. Yeah, I kind of went over that earlier, just reading my notes off here. Okay. Also, another thing I wanted to talk about is a different type of variable, which I did talk about last week. And I'll put it on the screen here as an example. So IN, for example, is equal, IN percentage is equal to 60. This is known as an integer value. So if you always type in IN percentage, you're going to get 60. I think if you try to divide it by 2 or something, it's always going to be, it's going to throw off the decimal point. So it drops the remainder every time. See how it's never showing the integer? But if I do, for example, II equals 30. Oh, I did that wrong. I'm so used to the other keyboard. II equals 30, and I do the same thing. II divided by 30. Oh, II divided by 30 is 30. Okay, that's why I got a 30. Oh, my bad. I'm not paying attention. II divided by, I need to do a lower number here, like 1 or something weird here or something. 3. What I'm trying to do is I'm trying to get it to print. I must be doing something off there or something. I'm in an integer variable is why I am. So the integer variable, these are both doing the same thing. I think I'm confusing myself here. So an integer variable can be entered either this way or this way. They're both going to be the same thing. That's what I was trying to say. Sorry about that. And later you'll see something like this on the screen. This is an integer variable of 2. It's the same thing, except you can use the BB percentage as a shortcut. Did that make sense to you, Romel? Or am I going too fast?
Sort of.
Okay, we learned about the string. I showed you that one earlier, so I won't go over that one. That's just the B strings equals the value, right? I think we had the AA strings earlier. I don't remember what we had. The B strings. I don't remember what it was, but I was just showing you examples. It will retain the data. It also will retain any variables you type here in integer. I should mention that. If you type any variables like in memory here, and we'll recall what we typed here as BB strings, and I'll send it off the screen here. If I still type BB strings, it'll still be here in memory until I erase it. So I could sit there and type like F1, just for example, and just say equals basic. And then say F2s equals playground. Like that, right? And if I just clear the screen here as an example, and if I type the values, you'll see they're still there. So they're there until we erase them. So even though we're not doing anything with our program, they're still being retained in memory in the background. And if I can remember any of the other data, there's AA. So remember AA we did earlier? So I remembered AA. I don't remember the other ones, the FP or whatever it was. Okay, you get what I'm saying though? It's always going to remember whatever the value was that was in memory earlier. And I can't remember all the ones I did, but I'm just giving an example that that's how immediate mode works. It'll still retain the values. And I use it a lot when I'm checking data and trying to figure out what program data values are doing. Okay, so I think we're ready to go forward because we kind of covered a lot of the other stuff. I don't want to go too much on that because we really want to get to the meat of the good stuff going on, which is writing this program and having some fun. As I mentioned earlier, though, we're going to learn about input statements in a program now. So if you guys are with me and you have any program in memory, if you were playing with it, just make sure to type in new to erase it so we can start from scratch here. If you recall last week, I typed this command. You just saw me type it earlier. This clears your screen. So print CHR string 147 will clear your screen. There's also a shortcut for it, if I can remember it. It's this one right here, which also does the same thing. It's just pulling that ASCII character on the character set, which is the 47 or whatever. Okay, so anyways, we're going to start with a program and move on to the next one for Basic Playground 2. And we can type in our little colon to kind of start the program. Are you okay, Romel, and typing this in now?
Yeah.
Okay, let me know if you get stuck on anything, as I want to keep everybody on track, and you're my guide here. So we're going to start by clearing our screen. I'm a pretty fast typist, so you have to slow my brain down sometimes. Sorry. And we're going to change up the screen here. I think I'm going to leave. Maybe I just go to blue. I think I'm going to keep it. We'll keep it black. We don't want to like go crazy with that. So what I've done is I just created a clear command, and I just created, if you remember earlier, a command to change the border color. That's this one right here. And also this one is for the screen color. And if you notice also, you can move your arrow keys around on the screen. We learned about that last week too as well. But now we're going to get in that input statement here in a second, I promise you. But what I want to do first is I just want to print a line by itself. Okay, and also I got your screen over here. I almost forgot myself to remind myself. I got you over here. I can watch you on the other window here. Okay, it looks like you're only on line 10. So let me have you catch up.
Accidentally cleared it all out.
Oh, you did?
That's okay.
Okay, just go ahead and type it in. I'll keep an eye on your screen here. I'm also keeping an eye on the chat and everything else going on here.
Is that a semicolon after the 20?
Yes. Just to kind of explain, guys, I have another window. I might mention this, but I have another window open where I can monitor her screen. And this tool, this screen sharing tool that's called Zoom.us, it's really cool. And that's what I'll eventually be doing. My goal is to be able to see anybody's screen at any one time. And if they ask me a question in a chat window, I'll be able to go there and say, hey, do this or do that, as I'm watching her right now. It's a perfect example here. Fortunately, I haven't figured out how to get Google Hangouts to do all this yet. So I'm just winging it for now. And she's typing in line 40 right now.
Oh, I messed that one up.
You forgot your, looks like you forgot your colon.
Oh, no.
You guys won't see her screen unless I share it. I can show it to you if you want to see it, but this is her screen right here. I got it in another window. Matter of fact, I think I'll keep that on the same window if you're okay with that, Ramil. They get to see what you're typing. Double whammy going on here tonight. Okay, so you can see that she's still typing in the program there. And that's what I'll be doing with you guys here. So I'll stretch this out to kind of demonstrate how this works here.
Okay, so I'm on 60.
Okay, gotcha. So this will allow me to switch between any screens here. This is mine. I'm the administrator, but this is hers. And if somebody else appears, and I have to send you the invite, I can keep track of anybody's screen at any one time. It's going to minimize this again, get that out of the way. And eventually this will be more organized. I'm still working this through, guys. Okay, so the next thing we're going to do is we're going to come up with a store name. Do you have any good ideas for a store name?
Mosquitoes.
Oh, I like it. She's picking on me because I've been attacked by mosquitoes lately. I can't even spell her. Is it Mosquitoes or something like that? Mosquitoes are us. There we go. I like it. Kind of a disgusting name. Who wants to go to a store called mosquitoes? I don't know. Okay, something else we're going to do here. I'm going to throw a loop in here. We learned this command also last week, which is going to change the text color because we want to make it look a little pretty on the screen here. So I'm going to choose a text color here of, I think that one is green, if I'm not mistaken. Actually, let's do the yellow just to start off. Yellow is always a nicer title anyway.
Oops.
And you can see her screen. She's just basically going back, and she used the arrow keys to go ahead and re-edit the line. I know you probably can't see her screen unless I enlarge it, but I can't really get them both on the same screen. Let's see if I can squish them maybe. I could turn off her chat, but I was demonstrating that this chat window is what I'll use to communicate with you guys here. So maybe I'll just turn off your chat for now. I can Alt-H. There we go. Oop. Trying to get that so I can grab it there. Okay, here we go. Okay, I think that would do me good right there. You can hopefully see her screen a little bit better there. So she's typing alongside with me here. So what we'll do is we'll type in another print statement. This is a carriage return, by the way. Remember, if you can also, last week we talked about you could just put a question mark in. It'll do the same thing. You don't have to do that though, Ramel. And now, how do you execute the program? Yes. I gave you the first letter.
Read or no?
Just R.
That's it?
What's the opposite of walk?
Run. Oh.
Got it. And you'll see your screen change red. You got a syntax error. This is exactly why we got a basic programming environment. So let me help you out with your colors here. Type in poke 53281.
53281.
Comma 0.
Comma 0.
And enter. That allows us to see your screen. Now type in list. And enter. It's always going to be enter after a command. Okay, let's see. This is called debugging. You learned something new, Ramel. I'll list my program on the screen and see if you can figure out what is going on with it.
220. $53. 8. I put 8 instead of 0. It, oops. So now where do I go?
You should be able to hear me.
Now I can.
You can? I just had to represent. Weird. Well, that's how I fixed the audio issues. Okay. I'm glad you typed that in. Thank you. Go back up to line 60.
Okay.
That's why she wasn't hearing me. And then go right in front of the mosquito.
Yeah.
And you're going to hold down your shift key.
Yeah.
Now, hopefully you can find this on your keyboard. You're looking for a key called insert.
Insert. Okay.
Press it a few times. Press it a few times, and I'll do it over here.
Now it's making a space.
Yeah, it's supposed to move over your screen just like that. Do it again. And then you're going to type in a question mark. So shift your question mark like that and hit enter. And you should be good to run it now. Go ahead and run it.
Oh.
Well, get down on your line there. There you go.
Enter.
Okay.
Oh, look at that.
Well, you got the colors backward, but you got to load that time, no errors, right? Just type in poke 53281 and we'll fix that for you. You just typed in the number wrong on line 40. This is very common mistakes. Nothing to be concerned about. You forgot the comma 0.
53.
281.
281.
Comma 0. There you go. Now look at your program. Eventually, I'm just going to say stuff and try to get you in a habit. How do you look at your program?
List.
Okay. Okay. Now look at line 40. You type 53281, comma 8, and that's a common mistake. Use your arrow keys, go up and change it to a 0.
Or after the first poke, the second poke.
Second one.
281 what?
Comma 0. The one you did earlier. You're changing in black.
Okay.
Now if you hit enter, you already changed that line. You only have to hit enter once, by the way. You already entered that line. Now you can move your arrow keys down and type run again at the bottom. By the way, if I mentioned it, I mentioned this last week, but this is Romel's very intro to programming. She is very brand new and she's picking up. She's doing a wonderful job.
Thank you.
You're welcome. Okay, so we're going to move on to the program now. We're going to start having some fun with it here. And I'm going to introduce something called an input statement. So I'm just going to clear my screen here to make it a little bit easier to see what's going on. Okay, so now we're going to go to line 80. You can list your program, or you can just type in 80. Yep, you got the hang of it. And we're going to type the word input. And now input can be a string. If you remember earlier, string is going to be any character except a keyword. And it can also be a value, which is an integer we learned about earlier. But for now, we're going to use a string. So we're just going to say input AN, which actually stands for answer. But we could just actually say input. It doesn't really matter at this point. Input, I'm just trying to use a simple word. Let's just do input A strings. Make it very basic. Okay, and you're going to say equals, or I'm sorry, no, not equals. I'm sorry. Actually, I'm sorry. I'm doing this wrong. My bad. Backspace, erase the input A strings. And this is because I was raised on a Atari 65 XE, and it's done differently that way. So my bad. You're going to type in a double quote instead. And you're going to say, how may I help you today? Question mark. And then don't hit enter yet. Okay, now hit enter. And now we're going to go ahead and run the program. If all is well, it should work. I'll let you run it first, Romel, and I'll run it. You got an error. I got an error too. Wait, what happened?
Very good.
You know what? I think I forgot my semicolon. My bad. I was wondering, question whether we needed it. Let me just run it again and make sure. Yeah, it needs a semicolon. That's why. Okay, I'll show you. After this, sorry, just use your arrow key at the very end. This time you don't have to do any inserts or anything. Here, let me show you a trick. You may have forgot this one. I should have showed everybody this one. Just type in list 80. Remember this one, Ramel? It's only going to show that line. There you go. Now you don't have to go through if you have like a really long program, that will save you having to go through a long program to figure out which line you're trying to change. And just change it like how it shows on mine there.
So how do you insert again? Oh, never mind.
You don't need to do that. We're not inserting because we're not moving anything. But the insert is the shift insert. Now hit your semicolon.
Okay.
Oh, you're gonna you learned how to insert anyway. See, she's picking it up fast, guys. Now hit enter. And you can just go down the line and we're gonna run it again. Now you notice what happened is now you see a flashing cursor next to two question marks. And I'll tell you why there's two question marks here in a minute. But just go ahead and type in something. Just say, let's just say, it doesn't matter what you want to say, because what we're doing is we're talking to a store clerk right now, and we wanted to pay for something. Say, I want something to eat. I'll show you why this is important now. Now hit enter. Notice our program is, so it's following sequentially. Now, if you list your program here, what we just did is we told the computer to tell us to receive information, but we haven't done anything with that information. Now, here's the trick to it. Now that we have already put in an input statement, type in print AA string, and you'll remember what we did earlier. Mel, what do you think it's going to say when we type print AA string? Let me throw you on the bus here for a minute.
Oh, I'm not sure.
What did you type just earlier?
Oh, I want something to eat.
Now hit enter. See, it's now remembering the variable even though we're no longer in the program because it's using the intermediate mode to still recall what you typed in earlier. The reason why is this is how the computer's memory works. It stores all this data in sequence. We're going to also remove the question mark because we got a double question mark. I forgot automatically the Commodore 64 will include a question mark. So just go up to the question mark there. And remember, you can also list line 80. So I should get in the habit of saying list 80 there. save you more trouble. And go right on the question mark. And just hit your space bar. Make sure it's right there and hit your backspace key. And enter. Now we'll run it again, and this time you won't get the double question mark. You're getting out of data because you haven't learned something about read statements yet. Notice you only got one question mark, right?
Yep.
Now you could just type in whatever you want. Give me a fly. Whatever you, or give me a human, right? So she's teasing me because I've been like bit by so many mosquitoes this last week. It's not crazy. I've bit over 20 sometimes, and I'm working on trying to figure out what's going on with my crazy desk. It's even biting me right now as I speak. So still underway. But that's another story to talk about. So what we're doing right now is we're just creating a crazy little program, and we're going to start working with our data. So let's go ahead and list it. You can always hit enter, by the way, Ramil, to get back to the line, in case I never showed you that. Like that, it'll always take you back to the line real quickly there. Just got to make some room here. So now we're going to continue along, and we're going to use some of this data to do some results with it. So we said, how may I help you today? That's just kind of using the computer as an interpreter, but now we're going to get a little bit more real. I just want to introduce the input statement, which is a silly little example. We're going to change this line now, though, and we're going to we're actually not going to use input. I'm sorry. We're going to start creating a store now. So if we can think of some items, mosquitoes are us. If you went into a store called Mosquitoes Are Us, what would you want to buy?
Blood.
This is getting really disgusting, but okay, I guess that's probably a bad example, but we could put blood if you want.
I can't get any quotations.
You have to hit the shift to get the quotation.
Yeah. Now what happened?
If you hit, there you go. Okay.
I was looking at the wrong window.
Okay, we're gonna say blood, right? And then we're gonna say comma. And how much would, if you had to purchase some blood, how much would you pay for some blood?
A pint.
Okay, so this is called PN for pint. We're gonna use that variable here in a second.
How come that does that?
What to do?
Mind. I think. Okay, now what?
We're gonna hit enter. Okay, we're gonna type in a new line here. Print. A good example. What's another example you would find in a mosquito store? Would we have a human or something? So we got the blood. They're going to eat blood from whatever animal they're going to get it from, but we also need a human since I'm the subject lately. So for that, we're just going to use the variable HU for human. You know, and just a silly little example. I didn't know it was going to get this bizarre. I was going to actually do a regular store, but she kicked it off for me. Ramel's a comedian, by the way, in case you don't know. Okay, so what else?
You should have known the answers I was going to give you.
What else would a mosquito want in a store? I'm ready to do a Google search here now. What else is mosquitoes like? Bugs, right? So let's put in bugs. It would just be you for bug. Okay. So now we're going to do, if you're going to remember, we're going to go back and list the program because we're going to insert some new lines. If you learned about this last week, and for those who are new, we're always going to start it by 10, skipping 10 lines. So if you need to go back and insert new lines, you can always go back and do that. So what we're going to do is on line 42, we're going to start creating our little variables here. So if I had to buy some blood, how much would I pay for blood? That'd be a silly question. Let's say a mosquito has to pay, because they're sucking my blood, I'm going to say $2,000. I'm not going to be nice. You better, every pint you give, you better give me $2,000 or whatever. You know, I'm not going to be happy. I probably want more than that. I'm just using a silly example. Okay, and actually that was just for the blood. Oh yeah, let's do the human now. So I'm the human. So you're sucking my blood. Yeah, I'm the human here. So I'm going to charge you 20 grand for that. So I'm making some serious money. You already sucked my blood 20 times. I'm making some money. Okay. Now we're going to type in the bugs. And bugs, well, they're going to suck. I guess I don't know if they do suck out of bugs' blood. I'm just guessing here. We're going to use I don't know, I said I wouldn't use floating points, so I'm just going to use a lower number, like 5 or something. We'll give them the cheap end of the stick, right? Now, if we type in our program and list it, it'll reorganize it exactly as we put it. So it took line 42 and inserted it in the correct place. Now, if we run the program, what do you think it's going to show, Ramel, by looking at it? What are the values going to be for blood, human, and bugs?
Blood, human. Oh, to put the number that we had.
Yep. So run it, and you'll get the results if we did everything correctly, which I think we did. Hey, we got a little store going on here. So now we're going to do an exchange value, right? So we're some alien from another planet. I'm going to make this really bizarre. And we want to purchase something from this store. I need blood to feed my colony. I'm a super massive alien, and all these aliens are dying, and we use human blood to save them. So I want to extract maybe, I don't know, 10 pints of blood or 10 points of blood or whatever. And then I want humans and bugs. So we're going to use that input statement now, and we're going to start receiving some values as a result of this grotesque program we got going on here. So you want to go ahead and list your program there, and then we're going to type in 110. Remember, we're skipping by 10 here, and we're going to go back to our input statement. So the clerk's talking to us. And this time we'll just call it BY for buy. Or I said BU. I don't think. Oh no, we're using BU. You can't repeat a variable, by the way. If we use B, well, we could use BU. It's a string actually, but you couldn't use BU or it would overwrite the value if you use it as an integer. So we use BU string just for buy. Hit enter. Now, if we run the program, well, we're not ready to run it yet because we've already seen this example. So now we're going to get some results of what our exchange's value. So what we're going to do now is we're going to make a tender, a purchase, right? It's called a cash tender. So we're going to use some variables now, and we're going to keep track of a result of a total of the number of dollars that we're carrying. So let's say we're wealthy or something. We're this big, massive alien from another planet. So I'm going to put, is that $1 million? Is that right?
1, 2, 3, 6 zeros.
Does that look like a million? Yeah. Okay. So hopefully I don't get an error. 32767. I might end up getting an error. We'll see if we can take up a million. If not, then we're going to have, it may not count that high. Because earlier I talked about the variables, integers. I didn't check to see how far integers would go. I think 99999. Okay. So now we're going to be this millionaire coming into the store. Those are going to stand for our dollars. And then we're going to get what's called a running total, and we're going to deduct it from this total. So we're going to say cash tender for CT. So basically, what is our cash that we're tendering in from the dollar result? And then we're going to take our dollar. So now it's going to take the CT value, assign it to the 1 million if all is well here. And what we're going to do is we're going to subtract this. And I did something wrong here. I just now realized. Let's see here. We got our count. We got the result. That's right. We can still do this. We're just going to subtract it from the total. But later we'll need to do input statements to keep track of which one we're doing. But for now, we'll assume the program understands. And that's probably another session we'll save for another day. But we chose the blood, so we're going to do minus PN like that. Now, if you had to look at that, Ramel, what do you think that would do? Remember what we did last week?
Run? No.
Okay, I got somebody saying they're missing a quote on line 80. Just trying to catch up here. The problem is I can't see their screen, so I'm going to take line 80 and I'm just going to retype it over here for them. This is going to get real interesting, isn't it?
Yeah, we're doing a lot better than we've been doing the last couple of weeks.
Oh, I forgot to do the 80. My bad. Yep. Yeah. I think we're in trial. Oh, and I did that wrong. I'm sorry. Sorry. I'm looking at the wrong line here. It's blood. He said line 80. It's that one. Last one. So type the last one. Okay, so I'm interacting with my YouTube chat at the same time. I'm interacting with Ramel in the window. So this is kind of a multitasking thing going on. So now that we got our running total, what we're going to do is we're going to print those results on the screen and show what the results of our values are. So if this is getting a little more complicated, stay with me. It's only going to get more fun. Now we're going to use a remark statement, which is very common for basic programming, to try to tell what's kind of going on here. And what we're going to say is, let's say remaining change. Good enough, right? You got, okay, she's right on track. I'm just watching her screen there. So our remaining change is going to be what's left of our dollars on the screen. And we're going to type a print statement, and you're going to learn now about something called concatenation. I know I didn't mention that in the actual announcement, but things kind of pop up as we go along. So we may not get into everything because this is kind of taking a turn of events, and the video is set for 2 hours. So my apologies on that. I had to present a little bit better, but I wanted to show you what I could possibly cover. So we may not get to arrays and all that, which is good because I have a friend anyway who wants to learn about arrays, and maybe he'll join us next week. But anyways, back with this, we're going to say your change or your remaining, your money, let's say your money left is, sorry, erase that, Ramel. Sorry about that. So your money left is CT. Just got to keep track of the total we had. Now, don't make it too complicated. If this were a perfect world, and I would have thought of this first before doing this off the top of my head, which I'm kind of glad we did this way because it kind of came out bizarre. I would have actually created a place where it kind of shows that first, this is your total dollars you have for this person. This is what the store has, and kind of like set it up that way. But it'll still work. Now we're going to go ahead and type in run, and we're going to type in the value of the blood because the blood's the one we're after.
Value of the blood.
Oh, yeah. We also got the double question mark, so I need to get rid of that again. Sorry. I have a bad habit typing. So the value of the blood, yeah, go ahead and run yours, Ramel. I'm glad everybody's actually able to see the screen, sir. Now hit enter, and it'll show you the remaining. Yay, remember the 1 million. See how it calculated it? Now it shows the alien's money left is, and you made a mistake on your money, it looks like, but that's all right. I made a mistake on the question mark. So we're going to go ahead and list the line. In your case, you're going to want to list line 160. And I'm going to list line 110 so I can fix the double quotation mark. Because you don't need a quotation mark. It inserts it automatically, as I mentioned earlier.
Oh,
But on the Atari computer, you have to use the question mark. That's why I've got habits of doing what I do. People always ask me, why do you do it this way? Why do you say this? Because I was very used to Atari computer, and syntax is different, and, you know, a lot of things are different. But I can program in both of them. Okay, so we got that. I'm just waiting for her to kind of catch up. She's getting really good at this. She's inserting over there. You're going to become a pro. I'm proud of you. So hit your shift insert there.
Shift.
Oh, you
okay.
now you have to type it again.
That's okay.
Right there.
I'm going.
You got it. Use your arrow keys.
Your money.
How's everyone doing?
Yes.
I'm just interacting with the audience over here while you're fixing that.
Ready. And then what do I do after ready? Then.
Okay, you just hit enter. That'll enter the program line for you.
And then enter again.
You can just hit your down arrow. If you enter again, you're going to get an error. That's just because you're doing something called a read statement. It was trying to read the value of y, but we haven't gone into read statements yet. So, but now we'll just list our program again. And we'll start having some more fun with it. Now, I did mention we were going to cover the input statement. The ASCII characters, we could probably draw a box around it or something, but we may not have the time to do that. As much as I'd love to be able to do that, maybe we'll do that next week. And I also mentioned that we were going to discuss arrays. So I think I'd like to get into arrays next, as much as I'd love to be able to make this program so beautiful. Okay. So we're going to introduce something called dimension and arrays, because if you're going to use arrays, you have to dimension it. Now, I'll get on to this reading from the book again, from the Programmer's Reference Guide I introduced earlier. Arrays can contain integers, floating point values, or string data types, and the data types have the same data as the array name. So let's go ahead and I'll introduce arrays now. And what we're going to do is we're going to use a new line up there toward the top. Since we used 42 earlier, I'm going to use 44. Just kind of skip down here, and we're going to use a dimension statement. Okay, so what we're going to do is we're going to store the result of all these values that for the store. We're going to restore the items, the blood, human, and the bugs. We're going to store these in an array that we assigned earlier. So it's going to get a little tricky, but stay with me on this. So what we're going to say, since it's actually a table, I'm just going to call it TB for table. And then we're going to assign the total values right now. Since we only have 3, I'm just going to assign it to 3. And then hit enter. Now, if you list your program, you'll see it put that in the appropriate place. So now I think by default, Commodore 64 will allow you to store up to 10 arrays before it actually starts asking you to dimension it. And I'm going to read the next. We won't go to that. That's two-dimensional arrays. We might not get into that tonight. So now we're going to assign these values. Now, if you look at line 42, that's where we originally assigned the values. And I think I just did this backward. Yeah, I should have assigned that first. My bad. Go up to line 42 here and just reverse these numbers like that.
What numbers?
I'll list them on the screen here for everybody to see. Those are the correct results. Yeah, I did it backward. You have to dimension the statement before all your variables. Otherwise, you're going to have problems if you don't do it the right way. Sorry, guys, that wasn't planned. This is kind of going by ear here. So somebody wrote list on the screen. I don't know why. Oh, that was me that wrote that. Okay. All right, so we're good here. You can type that if you want. What I just showed you, that's how to list a range of values on the screen. So it took values 42. If there was a 43, it would have showed up, and it also shows 44. That's just a way of getting to those lines real quickly and seeing a series of lines. So something new we learned here. Now we're going to assign that array. I'm going to use line 46 to assign it. And we're going to use the TB because that's what we called it, right? And what we're going to do, since they start at 0, so technically we got 4 here. We could start it at 0, 1, or whatever. We'll just start it at 0. Equals. And we want to set it to the value that we first assigned, which was PN. And we're going to have our colon after that. And TB1 equals, what do you think the next one's going to be? I'll put you on the spot again if you're okay with that, Ramel.
TB.
What's the next value? The next variable. Look at line 44, because it's probably not very clear on your screen. Actually, you may need to list your program.
Human, right? Human or PN?
H2 for human. Yeah, let's get a little more advanced. Sorry, guys. Just to kind of explain, if you're really lost right now, you can go back to variable. You can go back to video 1 and watch, because we talked about the variables earlier. That'll help you kind of catch up base where we are right now. What do you think the last one will be?
TB, HU, bugs, BU.
You got it. She is picking up so quick. I'm so proud of her. So now we haven't assigned them integer values, but we assigned them directly to the program. and we run it, it's going to keep track of these running totals. And let me introduce that for now. We'll just run the program.
BU.
I'll wait for her to finish there. Yeah,
No,
just
what
hit
did you say? BU enter? No,
enter.
what
You're
was
good. Enter,
what was
you're
after?
good.
But what was after BU?
No, just enter. You're good. Okay, now go ahead and run your program. And then we'll just type in the 2000 again for now.
Two. Oh, do I back up to
No,
erase one of the?
you're good. Just type in. You can do that later. I erased the question mark earlier. That was my fault. I'll try to break myself of the habit sometime tonight. Just type in 2000 because we're keeping track of the blood, even though the program's technically not keeping track of it yet. Now, remember, we're in immediate mode, but remember earlier we signed some arrays, right? Now type in TB0. Before you print it, what do you think it's going to show, Ramel? The value is on the screen, by the way. What do you think it's going to show? Do you remember what TB0 was? Table 1, what was the first value you see on the screen?
Table 1, 2, 20,000.
2000.
No. 1,000.
You're on it. You're on the right path. And then now if you hit TV1 in immediate mode, what do you think it's going to show?
Oops, I wrote 10.
Yeah, it's all right. It's good I'm working with you too because people would be so far behind if I weren't working with you because I could talk pretty fast. And this is, I love working with somebody directly. So what do you think it's going to show before you hit enter?
Table 1 is 5,000, well, 20,000.
Got it. Bingo. And the last one.
2, 5.
Bingo. So what we just did, what happened?
2, doesn't matter.
It's all right. She typed in print 2, so just basically printed the 2 to the screen with. But essentially, it's keeping track of arrays in memory. And arrays, if you think of it like something stored in a box, I may have an example to show people who really need to see a visual example here. Just realized I don't have a box to show you right now. But anyways, the whole purpose of an array is storing everything inside of a little pocket. You think of a place where you're storing something. I'm looking around to see if I could find something here. I knew I had a set of cups here somewhere, but right now I can't think of where they are. But anyways, this would keep track of things in a box. Anytime you put something in that box, it's going to hold a value. And then you think of it like having another box. And then another box is going to hold another value and so on. So it's basically keeping track of all these things that you're storing in a little box. Since I'm very visual, I'm going to switch to the screen here a minute just to show you what I'm talking about, even though I don't have a really good example for this one. So this is a little box I have. So essentially, an array is like taking this eraser I have and sticking it in a box, right? Now it's contained that value, and it's only going to hold that value until you take it out and you put something else in the box, which I probably don't have anything else to put in the box right now. But I hope you get the idea. It's essentially keeping track of whatever you're putting in. And then when you take it out of the box, that means it has nothing in it. It would be assigned a value of 0. I know, silly example, but hopefully that made sense. I think people will probably be okay, but for those who needed a visual example, I thought I would show it since I love doing visual examples. Okay, so back to this crazy stuff here. Let's get the Mosquitoes RS underway here. And my revenge, right? Okay, so now we're going to basically print these values that we actually result in these, and we're going to use them with our program. And now it's going to keep track of the values in an array instead of just assigning them to values like we did earlier. Now the computer is storing them in an array, and I want to show you why that's important, because you could print a series of arrays instead of having to make a bunch of actual individual variable values, which takes up more memory. So arrays save a lot more on memory. So what we're going to do here is we're going to, just thinking about this for a second, we're going to replace line 80 through 90 There's an 80 through 100 with our values. So you saw me do this earlier. You can list 80 to 100, and I'll show you those lines. Okay. I think your fan was picking up your picture there. I saw your picture there for a minute, Ramel. So I just switched you back out. Okay. So now what we're going to do is we're going to go up to line 80. All right. Why isn't this picking me up here now? There we go. That was weird. It wasn't letting me go up. And we're going to replace these with our arrays. I'm just watching her screen again.
How come it says PN? Should I put TB?
You're going to put TB because TN was the value. Earlier we learned about doing it this way so people understand the translation from variables to arrays.
Okay.
Now hit enter. And we'll do human next, or a table for human. That's a good question you asked. Does that make more sense to you now?
I guess.
John's like doing a great job, Steve. I'm like, oh, I'm trying to wing it here. Now hit enter. And then do our last one, TB2. And hit enter for that one. Now, if we run our program, it's not going to do anything differently, but now instead of using values for variables, it's using arrays in place of our variables. So we can still go back to type in our 2000 again.
Should I go up? No,
nope, you don't have to. You're on the same line. And yeah, you can move around on there because it's basically, it turned it into an editor is what it did. Just type in 2000. It'll keep track of wherever you are, unless you start putting it somewhere else where it shouldn't be. Yeah, because this is called an input prompt is what it's doing. It's waiting for you to put something at the prompt. Now hit enter. It'll still show the money is left over because we haven't added anything else to it. But now it's got those values in memory still. So in exchange of the TN, it's replaced them. We haven't done anything differently. I just wanted to show you. It's now using the arrays in place of the actual values instead. Just to show you that's how arrays work. I could probably loop your head a little bit here, but I'm gonna throw a little loop at you for a minute here and see it and test Ramel on this one because I think she'll pick it up and see if she figures out what this is doing.
Wait, so after that print and run and zero, I needed to put enter?
Yeah, you can just hit enter. You're just showing the value. You don't have to do that, Ramel. That's just an example.
Okay.
But watch this. Type that in right there. I didn't know I was going to go to loops, but I wanted to show you something important here.
FORX.
This is going to repeat what we were doing earlier. It's going to pull those values out of the box and allow us to see them. You can go ahead and hit enter because I know you're probably not going to know this until you hit enter.
Okay.
You see what it just did?
Yeah.
What do you think it did?
It put what the numbers are that we had the values before.
Yep. So what it's doing is it's sticking them in a loop. So this is a faster way to get them on the screen. So 4 is the first part. 4. Exec is any number you want to use. It has to be an integer. This has to be a number. Equals 1. It starts at the first element. And actually, I did that backward. We started at 0. So let's do the 0. My bad. That's where we got a 0. It was 0 to 2, wasn't it? Sorry. 0, 0, 1, 0 to 2. Yeah. So do 0 to 2 there. You don't have to erase the numbers. You can just do 0 to 2, and it'll do the correct values. Because I was thinking originally we started at 1, because I was thinking in that order of 1, 2, 3, but you can start them at 0. So now it's going to print the result, the correct numbers on the screen there for you.
Press enter?
Yeah, just press enter. It'll recorrect itself. Okay. You may not see the line it did because what it does is also it doesn't erase that line. So you may have to erase that line to see the correct one. So just erase that line like that, and then you'll see the correct value.
Okay.
You see where I am?
Yeah.
like that, and then I'll show you. Or you could also repeat it, but you'd have to type the whole thing in again. I know I cheated. I jumped into loops. I didn't talk about loops, but that was the only way I could really show you what was going on. When we were printing all those TB values earlier, when we were doing this, we were essentially pulling those values from a loop. And loops are going to be really important because later I could show you a trick here that allows you to run your program over and over again. It's called a loop. And all basic programs, a lot of programs out there, probably any program out there that exists, even games you play on the internet, they run in an existing loop. Basically, if they didn't run in a loop, they would end and the program would crash. Crash is like going back to your ready prompt. So what we're going to do now is we're going to append to this program and see what else, a little kind of fun we can have with our little bug fiasco we have going on here.
So now I want to go list for the whole thing again?
You could go back to listing it again.
Okay.
So I said we would skip the ASCII statements. We're moving on to arrays. I think we have enough time. Let's see, 9:45, 10:45. We might have enough time to probably go ahead and talk about the loops or whatever. I guess we'll get an extra bonus tonight. We can probably just, since we already introduced the loop, I think I'm just going to safely show people what loops are all about here. So we'll have a little bit of fun with loops and we'll probably come back to our program. So we're just going to do some running simple examples. Now, I think I might have showed you this one, Rommel, offline before. So she's catching on there because she's seen this. I think she's seen this offline before. I'm just waiting for her to catch up and anybody else is trying to catch up. And then hit enter. If you did it all right, you see what it's doing?
Yeah, numbers.
It's counting numbers in an array. Just like when earlier we did t equals 0 to 3. We could do something like this too, by the way. We'll just say items. This is what we did earlier when we were printing those values on the screen. I didn't mention, but a comma actually separates values. You might have saw the blood. You'll see it basically puts in a tab. It's called a tabbed line. And you'll see it separates it by so many spaces here. This is what the tab does. So this comma right here, example, is creating this space you're seeing between here. It's just kind of a fancy way of, editing it or formatting it on the screen. But this is what loops do. You could play, you could set them to go backward also. You just have to do a little bit of different order here. So we'll say 10 to 0, and you're going to hit a step, -1, print B.
2, 0. Wait.
You'll get used to kind of concatenating or squishing data values and programs together. That's how this Commodore 64 saves a lot on memories by keeping everything compacted together.
Whoops. Okay, now what?
Now hit enter. See what it did now?
Yep.
Counted backward. So these are just running results that you can put in a program. And any order you want to do them, you can also skip them over. So we'll just say A equals, let's say 10 to 500, step 5. And then we're going to print the value again. So this is printing the result of this loop. And then put a next after it. And you remember earlier, Rommel, when we were playing with the sprites off screen, this is exactly what we were doing. We were using loops to kind of move stuff around.
And enter?
Yep. And this is, you'll see it's counting by 5s now. Up to 200. Or 500, sorry. So it skipped every 5, and it was counting in the result of that. You can also use calculations inside of your loops as well. I'm going to do this one by 2s. And let's see, let's say 2000. We'll just keep it at 4. And then we're going to say AA times 2 or whatever value you want and hit next. So it's taken the value of this loop, which is 2, and then it's going to multiply it by 2 in increments of 2. So it's going to be 2 times 2, and it's going to be 4 times 2, and so on in steps of 4. But it's actually an increment in 4s too. So it's going to go actually 2, 4. I'm sorry, if I did it wrong. 2 times 4 is 8, and 8 times 2 is 16. So it's going to skip like that. So you're going to get some bigger numbers now. Run it. And you'll see how it's counting by the 2s, and it's using the multiplication factors in it to give you results. So it's like having your own little spreadsheet, huh?
Yeah, keeps going.
Yeah, it's a big one. Yeah, because it can keep going up to the value that you inserted. Now, this is good that we're doing this. Press your tab key, hold down your tab key. Well, it ended before we did. But you can basically break out of it. I think it's with the caps lock key, actually. But the tab key will pause it. So if you want to do it like this, for example, we'll do another one here. We'll just say 5,000, print AA, so we can learn how to. Hey, let's have a little bit of fun here. Put a little comment like that, and hit next. Watch what this one does.
Oops.
Now hit enter. You
Upside
typed it
down.
in there. Okay, you got to go back and correct your mistake. Let me see what you did there. Maybe I made a mistake too. Hold on. Oh, I made a mistake. It was my fault. I forgot the 4. I was thinking print. Had to be 4. Sorry, my bad. So let's just type it over again. Sorry. My head was thinking print, but I meant to type 4. So
F4.
like that. But you're learning about errors. So if you don't type in commands in the correct order, you're going to get errors, just like you saw me. So the mistakes I'm making are important for you to understand too, because you might wonder why these mistakes are occurring, right?
Yeah, then enter.
Yeah, and hit enter.
Oh my goodness.
See what it's doing now? It's tabbing the numbers. Now hold down your tab key. It'll start pausing. Now if you hit your caps lock key, it'll break out. That's how you get out of a loop. So I'm not going to go a whole lot into 4s. We'll learn them as we go along, but I didn't want to spend a whole lot of time. I just wanted to show you. Now that we're going to use 4s, we can have a little bit more fun. We can actually print the results of this data to our screen and just probably do some more fun stuff with it. I don't know where I was going to go with all that, but I just wanted to show you. These are actually going to be a way of keeping track of a large amount of data and printing the results to the screen very quickly. So, for example, we could print our results in a loop of our blood, human, and our bugs to the screen. And let me try something here. 170. So we got the results left of our screen. Unless you can think of anything else I could add to this, Ramel. I'm probably getting a little bit off track here, but anything else you think I could take this in a different direction with that loop?
I don't know.
Okay. So we got to run in store. We got a list of items. We're doing an input, and we're getting a tender total right now. So the other thing we can do is we could print our result of our money on the screen. So we could do that next to our money on the screen. And then we could show the result of all purchases we bought. I just now figured out what we could do. We could do a running loop to show our results each time. How about that? We're gonna go in a little bit more in this program than I bargained for, right? So what we're gonna do is we're gonna keep track of the running results. We got them stored in our arrays each time, but we need to store these in a total array in order to keep track of this. So we're probably gonna need to introduce a new array. Because right now, TV0 is keeping track of our blood, our human, and our bugs. But each time we run the program, each time we go back to the loop again, and we type in, for example, we go back. Remember, the input statement is going to always take you back to the input statement here. And it's going to remember whatever you type in for BU. Oh, that's what we got to do. Yeah, we need to say, what is BU going to be doing? So we're probably going to need to make this. I think I'm going to change this to the We're going to change this line. I got it now. Let's go to list 110. Because what we're going to make it do, what I should have done, is make it pick the correct item and show the result on the screen, right? So I didn't want to go this fast, but now we're going to learn about if statements. If we don't, we won't be able to get this program to go in the right order. I think I'm probably going a little fast for people here. Am I losing you yet, Ramel?
Sort of. No.
Okay. Okay. I'm glad I am not, because other people might be like, where are you at with this? What we're trying to do is we're trying to get a running store, and we're trying to keep the results that we typed in. In order for us to know what the results we typed in, we have to tell the computer which one are we picking. Are we picking blood? Are we picking human? Are we picking bugs? As I mentioned earlier, we also have to put these in a running loop to keep track of them in a running tally total. So I think what I'm going to do here next is I'm going to keep track of the running total in line 145. We can just call it TT. Actually, we probably don't even need to do an array. We can just use a TT. It'll keep track of it every time. So TT equals our running total each time. Let me think about this for a minute. So we would need to keep track of the number of results in the table. Okay, in order to do that, we would need an array. Okay, so we're going to need to assign an array. I had to think about that because we're going to keep track of the running results each time we get a total and append it to that to keep in track of how much money we're spending as we're going along here. So I guess we'll call this AC for account because that's typically what we're doing. And I'm just going to set this to a high value for now.
How come I got weird stuff?
What do you get?
I don't know. 42 p.m.
Oh, you're looking at line 42. Wait, why is your 42 different than mine?
I don't know.
Oh, you know why? Because I was. Oh, wait. We need to look at your program. Maybe you don't have something corrected here. Okay, see exactly what we needed. List 42. Okay, so list 42 to 44. I think you forgot to switch the numbers. That's what it is. You just have to switch the numbers. So go up to line 42. Remember earlier we had to do the dimension before it, and I forgot to do that. So 44, enter. Maybe you forgot to hit enter. That was it. Type 44.
Oh, I go back down?
Yeah, right where you are. Type 44 on top of the 42.
Oh.
We're switching those numbers. So type 44. We're replacing line 44 with 42. I'm sorry, 42 with 44. Hit enter.
Oh, there go 44. Okay.
To 42. Enter. So you basically just reversed them. Now if you list 42, we should be back on track where we want to be.
Oh, now I got all that.
You had to list 42 because you list the whole program.
Okay. So then I just want
42 only. Okay. I'm just going to set it to 100 for now. So you don't need to use your arrow keys to go back up. You don't have to type the whole line again. You could also type the whole lines again if you want to, guys, but the arrow keys save you more time, especially if you're not a really good typist. Oh, you left off your other parenthesis.
Oh. 43, 3. Oh.
Your shift 0. Oh, you left off your 3 now.
D-I-N-B.
Yeah, put your 3 in there.
3.
There you go.
And that's a comma.
Mm-hmm.
AC. Is that a 100?
Mm-hmm. So we're going to keep track of our account. We could run the loop 100 times to keep track of it 100 times, essentially. Now you can hit enter. I'll do it. Okay. I'm listening each time just to show you what we did is we added it to the line, and now we're going to create a line to keep track of our running totals. So in order to do that, we're going to say, and we're going to learn about something else I just now learned about. Oh, interesting. This is going to get so interesting. AC. So you can list, just type in 142, AC, And for now, I'm going to give it a running total. I was going to say TT for total, I guess. And equals our account total, not our dollars. So let's keep a track of what our tender dollars are each time. CT. Now I'm going to teach you something new again, which is probably good that we went over the loop. We're going to learn how to increment a number. An increment of numbers could allow us to get to the next array. If you remember that box earlier, I showed you the example of, we're now going to go from box 0 to box 1 and so on. Box 1 to box 2, box 2 to box 3, and so on, to keep track of what's inside of each box. It'll make more sense once we start accumulating it. So to do that, we're going to use TT equals TT plus 1. Now hit enter. And we can just list our program again. Okay, so now we told the computer to explain this to you guys. Remember, this was earlier our cash tendered, right? That we entered from our dollar amount. We had $1 million from this alien. He cash tendered the result of PN. So he's basically picking the result of a value that we had earlier here. But what we were going to eventually need to do is keep track of what this PN value is. And I'm going to show you how we do that next. We're going to go to line 110. And at the end, you're going to use your arrow keys, go up to line 110.
Up here?
Yeah, no, right you were just there. You went all the way up to the top. Okay. You're already there. Go right where my cursor is. After the BU $sign. Backspace, and we're going to erase that $sign. Oh. Try to keep track of my screens here, and I hit the wrong key. So like that. For some reason I keep trying to click off on my screen. I keep losing it there. What is up on it? It's just Google. It's this thing that's this window keeps popping up and it keeps interrupting my screen. It's driving me crazy. Okay, what is going on here? Okay, I'm hitting enter. There it goes. That was weird. Okay, so now we list our program. What we told it now to do is keep track of what's in our input statement, and then we're going to append this result to our running total on line 142. So list 142. And we're going to set it to BU.
One for two. Oh.
So change CT to BU for what we were buying to keep track of each purchase we're buying in an array. It's pretty cool stuff. This is real accounting going on right here, guys. Excel spreadsheets all the way.
Then now what?
Just hit enter. You can list the program again to make sure we're listed to make sure the results are looking correctly on your screen. So I'll pause there for a moment if somebody needs to see it, because people might be saying I'm going too fast, because I know I could talk a mile a minute, but we only got a 2-hour session here too. You can always watch the video if you need to. Okay, so now that we have everything in a running loop, what we're going to do is we're going to run and make the program return back and keep asking us, what do you want to buy today? It's going to show us the result. But in order for this to look good, I think what we're going to need to do is we're going to need to pause it for a second so we can see it. Otherwise, it's going to go so fast, you're not going to be able to see things very quickly. We always want to see the result of the remaining change each time. So what we're going to do is go line 170 here. Since we learned about the loop, you're going to learn what's called an empty loop. It's known as a delay loop. You're going to use DL for delay. And I'm going to set mine to something like 2000. We may have to play with it or something like that. And just hit next. Speaking of mosquitoes, I think one just bit me on my finger. Okay. Now we told the program to pause before clearing the result of the money left. And we're going to learn about a new command now. It's called goto. We want to go back to the program, but we don't want to make it initialize the data on the program. So essentially, we can make it go back and clear the screen each time. But for now, I'm just going to make it keep pending everything back to the screen. And you'll see what I mean here. Because if we go all the way back here to line 44, for example, it's going to reset all of our variables, which we won't need these anymore, by the way. And we don't want it to keep rewriting these over. We want it to remember every value we're typing in over and over again. Essentially, we got a running total here, so it probably would still work anyway. Let me just test this for a minute. CT, so TT equals BU. BU is the result we're typing in. CT is keeping track of DO and PN. Yeah, it's keeping track of what DO and PN is equal to each time.
How come I have CT on 142? AC equals, I need to redo that, right?
Oh, yeah, make sure your program, this might be a moment to check your program too, guys. I'm just going to type in the result of what I think it's going to work. So we could just use line 60. And actually, I'm just going to change it like this. Even though it's kind of redundant, we could have done this a different way, but for now, we'll just make it redundant so we can clear the screen each time. It'll look more professional that way. Sorry for all the mistakes I'm making. I'm still doing this by ear here and just kind of playing it along. Go to 60.
60.
Go to 60. So what go to is doing is jumping back to line 60 after we've gone through this program, and it's going to allow us to go over and over and over the program again. Now, the only thing we didn't do, though, is we do need to do an underline here. So I'm going to have you listed again. We're probably going to have to insert an underline here because we need to show the result of the running totals, because right now it's showing your money left is CT, but we want to basically keep track of the running totals of everything that we're doing. You'll say your account, today you purchased ... We'll do something like that. I think that'll probably work. So your money left is CT. So we'll do 162 to make this a little bit clean and do a carriage return. Let's just get by twos again. And say something like, or today you purchased, and it's going to keep track of everything that we purchased to the screen and a running total each time. And I should have actually done this in the loop because each time it's only going to show us the results. Let me think here for a second. It's going to get a little more complicated. I'm not trying to make this too complicated, but we'll just do 3 results for now. I think that's the only way I can really do this. So we're going to say AC for the total. Remember about the loop we did earlier? We're going to create a separate loop in here. And I'm just going to call it LL for loop, I guess. And remember the lines we skipped earlier. So we're going to insert a line above that to give a running total of this loop. Let's see. Actually, it's 0 to 3, is it? 0 to 2. My bad. LL equals, just keeping track of our running total. So actually, technically, we could start this at 1, 2. It doesn't matter what you type it at. Sorry, Ramel. I just try to teach them. You could do it in orders of 1, 2, 3, or you could do it as zeros. I just want to show you, since we're keeping track of the running totals in our account, I'm just going to do 3 for now. And let's list lines 163. Actually, I'm doing this wrong. Okay, I'm trying to list only those lines. So let's just do this 160 dash like that. That'll list everything to the end there. You learned a new command. So if you type a dash after a line number, it lists everything from 160 to the end of that line to the end of that program. It's a way to list a series of lines to end out the program. And a shortcut you'll learn about. So what we're going to do is we're going to finish this loop. Otherwise, we're going to get an error. So 166, we're just going to put a next there. So it's going to print the results to the screen. We may need to increase our delay loop to see it. And each time, it's going to show us what we purchased on the screen and a running total. Now let's run this and see what we got going on here. We may get some errors, but we're playing this by ear though, right? What did you want to buy today?
Oh, I got errors.
You got an error. Okay, I'll jump out of mine and see what you got going on. List 44. I'll list 44 for you. Oh, you never flipped your lines yet. List 42 to 44. You're not doing something right with those 2 lines, I think. You have to reverse them. That was my fault. If I had done this more constructively, I'll try to have a more constructive program. You got 2 dimensions going on there. That's why. So technically, let me see. We got rid of these lines earlier, but and then we're still utilizing them here. So I think we'll still have to.
My line 44 is way different.
Yeah, you'll have to just retype it.
44.
And again, the mistakes she's making, everybody else could be making their mistakes too. So nobody's perfect.
Whoops. Equals PN equals.
I just noticed my screen is not presenting again. I think this video is going to be really bad tonight. It wasn't presenting the screen again.
Then I press enter.
Yeah. Probably for the good anyway. Okay.
Okay.
You should be good now. Go ahead and run your program.
Run?
Yeah. I'll run mine. And now you can just type any one you want. Let's type in
Well, I got
Q.
2 question marks.
That's just because of earlier. It's fine. It's not going to matter. Because you didn't erase the question mark in the program because of my crazy habit. But just type in exactly as it is.
4 zeros. Okay.
And hit enter. And I got an error here, so I need to find out what's going on. I think I know what it's doing.
Oh, no, I got one.
It's basically because I forgot to set it to 0, and I did these backward. I'm probably going to have to reverse these 2. See, I'm making some mistakes, but as I'm making these mistakes, I'm learning from it. So list these 2 lines right here. Sorry. Right there.
142. 144.
We're going to just reverse these lines. And I'm probably driving people crazy about it. So why couldn't you get these ordered better? I'll probably get a lot of hate comments, but I'm like, well, I played it by ear, so this is what programming is all about. It's called debugging, getting it right. And then this one's going to be 142. Because really what it was doing earlier, it was trying to start with 1, but we originally started at 0. So this one, we had to keep a track of the running total at 0 because we incremented it by 1. If we left it to 0, it would have been fine.
Out of data.
Yeah, it's just because of the read statement there. You'll learn about that later. Just hit run again and just pick anyone. I'm just going to pick the bugs. You can pick anyone you want, though. It doesn't matter.
How come I don't have anything under blood?
Oh, you got an error there. Hold on. Let's see what you got going on. See, this is exactly why we need to do this. Let's look at line 80. See what you got going on with 80.
I don't have any blood.
Okay, hit enter. And then you're going to need to hit your caps lock key to get out of the loop. Hit caps lock. There you go. List 180. You got an error 180 too. Exactly why we're doing this. You have your go-to statement wrong. Go over to your go-to. You have a 0 in there.
Go to what?
60. So race back. You have a 6 starting with a 6. So race back to the 60 there.
That one is
Now race
60
back.
to 60?
Yeah, you go back one more. And
Oh,
type go to.
What?
GOTO, go to.
Go to 60.
Yeah, you got it now. Now you can hit enter. You're good. Okay. So anyways,
And then run?
Yeah, no, list 80. We're going to picture line 80 now. Because you got the TB earlier. You did something wrong there. Let's see what you did. I see what you did. Look at, you forgot the double quote. So type in, I'd probably just retype it in unless you want to do the insert. It's up to you. You could insert it.
After D?
It's going to be one more over. Yeah, now do the shift insert. Now hit your double quote. Enter, and you should be good now. Myself, I'll retype the whole line.
Run?
Yeah, run. Now we're going to type in a result. I'm just going to choose the blood. You choose anyone you want. Doesn't matter.
How come?
and hit enter. And now you'll see what it said. You have an issue with your 42 and 44, I think, again. Let's find out what you did here. Yours didn't get the running total correctly. List 140 to 142. Type it in. 140 to 142. Well, you gotta get out of your program. You're in your program now, so hit enter. Hit your caps lock key to get out, remember? Hit enter. Caps lock. Gotta do it fast. There we go. Now let's 140 to 142.
Take the caps lock off now? One.
No, you're good. No, you just type them over. Well, you can just type them over if you want. It's not that much to type. Don't do that. You're going to erase the line if you do that.
140 CT DO.
I have a feeling I might need to extend these Hangouts longer based on what I'm learning here already. Because there's going to be, imagine if I'm like trying to teach 10 people and they're like, I'm stuck here, I'm stuck here. This is going to get real interesting. I'm going to have to come up with some kind of an algorithm to figure this out. This is my first time doing this live teaching session, by the way, guys.
Okay, now what? Ready?
Now you can go ahead and run it. You should be good. You can pick any value. I'm just going to pick the bugs. And it'll show you what you purchased. Now, you might be wondering, why is it saying today you purchased 0, 5, 0? Run yours. Hit enter. We'll type a value. You didn't type a value. Type in a value there.
After 5?
Mm-hmm. You type in 5, any value you want.
No, enter?
Yeah. I think you must have something still going on with yours.
Obviously.
Type in 5 again, or we have a bug in it. I haven't checked yet.
Oh.
Yeah, there might be something going on with yours. Let me see if mine's doing that, by the way.
5.
No, you got a bug in your program somewhere.
I hear mosquitoes or my.
Exactly. Okay, hit enter and then press your caps lock again to break out a loop. Remember, if you don't do it fast enough, it'll go right back to the input. You got to do enter again. Caps lock.
Ugh.
You got to do it right when you're running in the loop there. So just hit enter, hit caps lock.
Enter, then caps lock?
Yes. There you go. Because you're breaking out of a loop. Remember that running loop you were running earlier? Now, I listed mine on the screen. Go ahead and list your program and see if we can figure out what's going on with your program. At the same time, I'll track it down for you, unless you can see what it is here. So earlier, yours was printing. I see you got 144 wrong. Okay, we'll fix that. I'll list 144 here for you, and you just retype that. I just got to go back and get on the screen. And why does it do that every time? Okay.
So I put 144.
You weren't keeping track of the array. That's why it wasn't working.
GT equals BU.
And hit enter.
Then what?
You could go ahead and run. I'm going to introduce something else to somebody. We're just going to make sure yours is working again. And you have to break out of the loop again.
Keep getting double question marks.
That's because you have to fix the input statement, which is further back in the program. You don't have to erase the input statements, but if you want to fix it, we can fix that.
I'm not going to worry about it now.
Okay. Hit enter. It should be working now. There you go. Yours is fine now. Now type another number. Type a different number.
Anywhere? I mean...
No, right where you are. Type a different number on the screen. And right now, this is called a dumb program. Later, we can make it say, if you type in 2 for blood, it'll say, that's not how much blood costs. If you type in a different value for human, that's not how much human costs. I don't have that item. That's called a smart loop. That's conditions. But we're just doing something simple and working our way up as we start spotting these bugs, right? Perfect example. I love how this one turned out. Okay, you can break out of your loop. Remember how to break out?
Oh, enter caps.
Perfect. Now list 163 to 166, like I did.
One.
Okay, so what we're looking at, what I was talking about earlier, when you were seeing, remember when it said today you purchase 5, today you purchase 0, today you purchase 0? That's a little confusing, right? So
Yeah.
what it's doing is it's reading the loop here. So if you look at line 163, it's reading it at L1. And if you look at your account over here, AC equals LL. So here's how you can see what ACLL is. Go down here to your ready prompt and then type in print AC1 or account 1. So what it was doing is it was keeping track of the data values that exist in this loop. So LL2 is like this. And you notice it has, mine has a 5 in it because I ran mine twice. It's showing the running total each time. So go ahead and type that one, Ramel. If you typed a different value, yours should be different. I think you might have typed 2000 in yours. Go back up to that print. And I have a feeling our stream's going to end here real soon. I don't know if it's going to end or if it's going to continue because I set it out to only 2 hours.
So
Okay,
enter?
yours, enter. So yours, you entered 2. You notice how mine says 5 and yours says 2? Earlier, you entered 2 and just keeping track of 2. And if you did it 3 times, it would keep track of the third value. I didn't do mine 3, so mine's 0. Go try yours and look at the third value. See if you typed in the third one. I don't think you did, but just for example, go back up to the line and see what we get.
Enter.
Yep. Now you did yours 3 times. You see how it kept track of 5 the first time, it track of 2 the second time, and 2 the second time. So it's called a run-in tally loop. So now the program is smart enough to tell you what the alien is keeping track of each time, right?
Yeah.
We could make it a little bit more different, but we're pretty much right at our time here. I just wanted to show people this is the result of a running loop. I'll go back over and explain this because it might be a little confusion to some people. So just breaking it down line by line here, for example, we'll start with 10 to 50. That's good. So essentially, line 30 is clearing our screen, as we learned about. Line 40 is setting our border color and our screen color. Line 42, which I'll list here, is called a dimension loop. It's dimensioning a value in memory to keep track of the total in our array. And our first TB we were doing was keeping track of the results of the items from the store, the blood, the human, and the bugs, right? So we had 3 items there. And the second one is keeping track of our account up to 100 times. So we could actually run the program 100 times, and it would actually keep track of 100 values. And you could keep track of up to, I think earlier I said it was, I don't know if I mentioned, I thought it was 32,767 or something like that. There's a total number of values you can store in an array. I don't think I talked about that very well, but we just did 100. So essentially, you could make it keep track. You wouldn't technically keep track of it 100 times because if you're going to the store and you're buying these items 100 times, unless you're buying the $5 item, you're going to run out of money, right? Yeah. So eventually, you're going to learn about conditions. You're going to learn how to check for a value less than 0 or equal to 0 and say, ha, you got no more cash. Sorry, you can't buy anything. Works like in the real world. But we won't go into that because we don't have time to do that tonight. But this is a good program, I think, to kind of build our basis on for our little store. A little bug store, so to speak. So I'm going to go down to the next slides here and explain these in order. So 44 is keeping track of the value for our PN, which was that our blood or something there? I was probably thinking pint of blood when I thought.
Pint, yeah.
Yeah, pint of blood. And then our HU is for our human total, and BU is for our bug, as she's already picking it up. Good job. Next one is keeping track. Oops, look at what I did. I typed in lost. 46 is keeping track of our running total we assigned earlier from our dimension. Is keeping track of the value of TB0, which is our running total of our pint the first time we run the program, second time, third time, and so on. Just keeping track of all these. Actually, that's not the one we have running for the tally, but right now it's just keeping track of individual values, excuse me. So it's only keeping track of the value stored in PN each time. So that would be the, whatever the number was, or I think it was, what was it, 2000 or something like that. And in the TB1, it's going to keep track of the human value, which I thought that was 20,000, I thought I set it to. And in the TB2, it's keeping track of the 5 value we set for the, what was it, the bugs. And now going on to the next line, which I think was 50. Let me just go through to make sure here. I don't skip anything. Yeah, 50 is just doing a carriage return. So I'll just list 50 to 90, for example. And line 50 is doing a carriage return for a print statement. The poke 646,7 changes our text color. If I didn't mention that already, it changes it to yellow. You could go here and change this to any value you want. You get a different color. So if I do 13, for example, that would be like a light green or a lime green. 60 is a result of printing values on the screen in what's called a string. Essentially, if you got 2 double quotes, it's printing a whole string of characters, because this is what this is. It's a whole string in between here. Just keeping track of the results between your double quote and your double quote. And then you got a print statement. You got the same thing happening here, with the exception you have the comma, which serves as a a tab dot. It's tabbing over the number of spaces for the next print value, which is our array here. And that's the same thing the human's doing. And then, of course, on line 100 going down, I'll just say 100 right there. So 100, you can see it's keeping track of the bugs as a result. Now, here's the one that Ramel wanted to fix earlier, is 110. List your 110, Ramel. It was driving her crazy. I noticed that. Move your arrow up just like that. And hit space. And then backspace. And then enter. Now, if you go down to list 110, the question mark should be gone.
Okay.
Yeah. If you want to just list 110, you'll see it. And I'll continue on here. So I'm going to say 111. The next line's down. Okay. So the next values here, is your question mark gone? You did 111. You got list 110.
Oh.
Okay, so the next one does a carriage return here while she's doing that. The next one is assigning our variable for our dollars, keeping track of the total dollars that our big alien from the other planet has. He has $1 million, right? And over here you can just even do something like alien money or something like that. Keep track of what that line is doing. You'll have later using remark statements to kind of keep track of what that result total is doing. And then this would be the cash tendered we learned about earlier. And this would be the running total of the account. So stuff like that would help you keep track of what these variables are doing. So if you look at this, it's keeping track of the dollars. This one is keeping track of our cash tendered. So it sets a value first to 0, and then it assigns it to the first value you put after it, which is DO. So this is DO is going to be equal to 1 million. And then we learned about this last week. It's now subtracting the value that we entered earlier for the pint of blood, which I think was the 20,000 or is it 2,000 or whatever it was. And it's going to keep track of that cash tendered. Now, I probably didn't explain this very well, but this one is a running total. It's known as a counter. So TT just stands for total. We're basically increasing TT by 1 each time. So if you want to see that, for example, if I go down here and set TT equal to 1, and I print TT, you'll see that it's already equal to a 1. But now if I set it in a running loop here, I did minus like that, and I print TT again, you'll see it's now a 2, and I could do it again, right? 1, and print it. And what do you think it's going to be now, Ramel?
3.
You got it. So it's keeping track of that running loop that we had earlier at line 140 there, or 142 it was. So each time the program ran, it knew what TT was, and it just kept increasing. The first time it's 0 before it gets here. Now it's a 1, so it's able to put that 1 into our account total, which is why it didn't work the first time, because I didn't have them in the right place. So it was reading it as 0, and there was nothing assigned here, so it was reading it as 0. So we had to reverse those lines to fix our bug. And it's keeping track of the value we entered at our input statement for our buy, or BU, and that keeps track of the running total. Down here, it's telling the money we have left by reading the value of the CT up here, which was our cash tendered, of course. And notice that each of these keeps track of their own individual data, right? So that's what variables do, is they keep track. As long as you're not assigning them each time, it's always going to keep track of the result that's in that variable. Pretty straightforward. And then it does a carriage return. Line 163 is just a loop, as we learned about earlier. It's counting from 1 to 3. Now, technically, this would be a bad example because it only could read the program 3 times. But I just did this as an example to show you. Later, we would just do something like an LL equals +1 and just append it to this to keep track of a constant running total. But I didn't want to make it too confusing. That's why I only had you run it 3 times in a loop. But if you wanted to increase it to 10 times, you would just change it to 10. It would keep track of the program running 10 times and keep track of all your running totals each time. And it's always going to say, today you purchased, since it's repeating this line over and over again. So here's how a for loop works. It says for, give me the value of LL. Now LL is first 0 until we assign it. This equal, assigned it to 1 now, started at 1. 2 says, how far do we want to go to? We want to go up to 10. Now LL is still 1 because we haven't done anything with increasing it. Now it says, okay, print this on the screen. Today you purchased, give me a space there. And after this, append the variable, so the array of account to LL, which we know is 1, right? Because this is LL equals 1, assign 1. When you get to next, though, what it does, it actually increases the value of L. So now it's saying LL equals LL plus 1, as we saw earlier. Now when it goes back here, it's actually 2. So now if it goes here, it's reading the account value of 2. Does that make sense, Ramel?
I think so.
Okay. And it hits the next again, right? And it says now it's 3. Now LL equals 3 to 10. And now over here, it's going to say AC 3. So now it kept track of 3. And then it would go to 4, 5, 6, until it reaches the end. And then it would hit our L or DL down here. I didn't want to confuse you by using the same variable because you could technically use the same variable. But we got a separate variable here for delay to pause. I probably didn't explain the story, but this is a pause. What this is doing is saying, read me up to 2,000 increments, which are known as timing increments inside the computer, and don't do anything after. So you notice it just says next, right? So L equals 1, next, L equals 2, next, L equals 3, and it's doing that all the way up to 2,000. So as a result, since nothing is printing or showing between there, it's just waiting. And that's why you saw it pause, like I was telling you to hit the caps lock key. Remember that?
Mm-hmm.
It was pausing, so you had time to hit the caps lock key. And then finally, we clear the screen and we go back to line 60, and line 60 just starts the cycle over again. That's essentially what we have going on. There's probably some bugs in here somewhere, but we ran out of time, so I didn't want to go too far over. We might have kicked it. It looks like our stream doesn't stop. That's good. I wonder if our YouTube is still going. I think it is. So I think we're good for now. I would have liked to gotten into more things, but I think we covered a pretty good running program. Would you say so for now?
I would think so.
Think it's interesting?
I think so.
It's going to get more interesting as time goes on. Because eventually we're going to imagine this. Alien walks in the store. He's okay, yes, I'd like to purchase some blood. I'd like to purchase 5 pints of blood or 5 gallons of blood, what do you want to call it? I'd like to purchase 17 humans. And I'd like to purchase, remember he's got $1 million, right? I'd like to purchase about, since bugs are cheap, give me about 2,000 of them or whatever. And the result of it, it's going to keep track of all that data. And it's going to keep track of what his running total is each time until the alien runs out of money. You know, eventually he's going to walk up and say, Yeah, and he's already got no money left in his account. I'd like to purchase 5 pints of blood, and the store manager gonna be like, no, you don't have enough money in your account, so I'm gonna deny your purchase. This is what is when you go to an actual store. This is exactly what your cash register is doing. It's keeping track of a running total at the register and the money you're tendering. Of course, the cashier is a human, and they know to put that in. But when they enter into the computer, it's keeping track of the results they're entering into that calculator. This is exactly the same thing. Of course, this is a more higher tech computer, LCD screens, all that stuff they have going on these days. But essentially, this is where it all began. So. Hope you found this interesting, guys. Be sure to go ahead and rewatch the video. I noticed we had 8 people watching to the end. Probably lost them when I was probably stuck in a loop there or whatever. But I think it was a pretty good turnout for the most part, when you say, Ramel.
Yeah, and actually, we didn't have any bugs this time.
We did have a few bugs.
Not major ones.
Yeah, I didn't have major bites on my side over here. But I think it turned out pretty good. So I just want to thank everybody for watching. Definitely go ahead. I appreciate your subscriptions. Help me grow this channel and support me on Patreon if you can. I appreciate it very much. I'm looking forward to seeing this thing take off and really go forward. Like I said, eventually I want to have it where you go in here and you have just like lines of people here talking to me, and I have conversations going on. And of course, once I didn't explain this to you, but once people start joining the Hangouts, like you or Ramel, you could talk back and forth to them.
Okay.
Isn't that interesting? They could talk back and forth to you, like we're doing right now. Several people could be talking at the same time. It's a live environment. It's really cool. You want to take turns. You can share the screen only once. So you take turns doing that. Usually as each person talks, their video and their stuff is going to show up as somebody else is not talking. But that's kind of what the goal is, to really try to interact with more people. If you guys have suggestions of how I can improve this, please let me know. I love hearing your opinions. I love hearing your feedback. It's what's going to help me continue to grow. And I hope you enjoyed this session. We had a great time here, and it's already midnight here in Arizona. And we'll join us next week. We'll be here next week at the same time, same bat channel, 9:45 Mountain Standard Time. You guys have a great night. Say bye, Ramel.
Bye. Good night.